that wraps up the modeling portion of this real-world CAD challenge. It is a pretty reasonable demonstration of some of the stuff that you'll actually have to be able to figure out when working with weldments and welders in general. And if we hop back into our drawing, we can see, so I actually went and made this leg. So I broke up the assembly into individual components, which in order to do that, you can go to drawing, or you can go up here. Let's grab a front view. So what you can do is if you click this, you can do select bodies and select a body. And now you have just that single piece in the CAD file. And then I also did that for all the other pieces. So these are all full front views that I just selected individual bodies of so that I can dimension each piece individually start to finish. Because when you go to start making this, you want to see this angle, and the length on an individual piece so that you can see what you actually have to make. If it was all dimensioned in a single thing, it starts to get extremely messy and hard to interpret. Breaking it up makes it a lot nicer. One other thing that can make fabricating something like this nicer is how I do my angles. So if we look at some bandsaws, being with the blade being 90 degrees to this fence, that's what most bandsaws will call 0 degrees. So in CAD, 0 degrees would be considered straight. So if we go to pull an angle here, we would get, on this dimension, normally you would get 71 degrees, 71.6. So instead of making it so that on the shop floor you have to calculate what this angle is, I like to add in a line. So, and how I add those lines in is I grab a center line and I go from this point down. Let's just pretend this is over here. And then I click this one, and I click this, and I say to make it perpendicular. And then I can grab my dimension from this vertical face to this so that you can, the welder or fabricator can actually see the number of degrees the saw needs to move in a certain direction. That alleviates a lot of math in the shop floor and saves potential errors and also time. We can go ahead and delete that guy out of there. So, and I do that for each one of the angles. So when you're going to actually set the saw, these are the degrees that you're actually going to use. There's no math involved. And then the other thing, when making a cut on a bandsaw, you have to lay out the lines. So most of the times it's nice to lay it out from, if you have a piece like this, it's nice to lay it out long to long. You don't want to come into this point. It's very hard to measure if you're going from this line to up here. When you have a miter piece with the angles both going into each other and complementing each other, that's not so much a problem. On these vertical pieces, however, on this piece, we have the bevel going this way on one side and the same way on the other side. So it makes it a lot easier to accurately measure this if you pull a small line up to dimension from. That way you can do the long to long measurement, and when you go to scribe your line, you'll just scribe from this back face, which makes it a lot easier to fabricate. I think that's all for the fabrication tips. Yep, so always try to go long from long if possible, and don't dimension a long to a short. It's a lot harder to be precise with that. Other than that, I think that concludes this drawing. You can also see these end caps ended up being different angles. The larger this bottom one gets, the more different these ones are. But I believe this is concluded. So that was the Real World CAD Challenge Misaligned Leg. I hope you guys had fun building it.